Hello, everyone, and welcome to the latest edition of our Lightning interview series. Happy Friday. And always, we like to make these sessions interesting and interactive, so please do introduce yourself, tell us where you're joining from, and of course, what you do. So today's interview, as you can see, is with research scientist Dieuwke, who is from Facebook AI Research, otherwise known as FAIR, and also an advisor to the European Lab and Learning and Intelligence Systems based in the beautiful city of Amsterdam. And today's topic, as you well know, is NLP's generalization problem. However, before we start, I want to have a few quick words about upcoming events at ODSC that you may be interested in. So as you can see there, quite a busy summer for us going through July and August. On July 26th, yours truly will be giving a 3-hour training session on data wrangling with SQL. And as you may know, SQL is consistently ranked one of the top skills for data analytics, data science, machine learning, and all those very interesting roles. That's quickly followed on July 28th by a free webinar on CPUs and GPUs for your end-to-end data. And after that, on August 4th, we have a webinar on PyTorch for large-scale distribution training workloads. And continuing our busy summer, on August 9th, we'll have another webinar on applying weak supervision in NLP tasks. So another NLP session coming up there as well. And then coming into the autumn or the fall, September 8th and 9th is our ODSC APAC conference. It is hybrid this year. Most of it will be taking place virtually. Lots of free passes still available for that. And we are setting up, ERA on our team is doing a great job of setting local meetups in Delhi, Bangalore, Tokyo, Singapore, and Sydney. That list may expand a little bit or contract as we find those meetups. So if you're in those regions, please do join us in person and connect with your fellow data scientists and attendee. And our last big event for the year will, of course, be in South San Francisco on November 1st through 3rd. We are back in person. Actually, we were in person last year as well. It went pretty well. So really excited for that. And as part of that, we do have our ever popular mini bootcamp, which will be starting up. And as part of that, you actually get access to our AI Plus online training system. And if you're thinking about the role of a data scientist, data analyst, data engineer, this is a really good starting point for those of you thinking about a career in data science and AI. And don't forget, all these sessions are on our AI Plus training platform. I think there's about 400 or 500 courses on there for free. And then if you want access to some of our bootcamp courses, I think there's a deal going on at the moment. But anyway, enough about that. Want to get into our main topic for today. And Dieuwke, welcome to the show.
Hi, thank you. Thank you so much for the introduction. And it's very impressive. So many events. Well done.
Yeah, well, you know, we like to keep busy in the summer. And, you know, there's so much great content out there. We want to keep it flowing. So why stop? And Dieuwke, first and foremost, you were a speaker. Speaking of events, you were a speaker at ODSC Europe in London. And thank you again so much for that. It was one of our highest rated talks there. So really glad to have you there and definitely want to have you back again. But as we get into this, just tell us a bit more about your research and your role at Meta, if you don't mind, before we get into the topic itself.
Yeah, absolutely. I'm always very happy to talk about these things. So yeah, as you said already, I'm a researcher at FAIR. I think my official title is research scientist, which has always been a bit puzzling to me because don't all scientists do research, but maybe it should like doubles up in that way. So I joined FAIR almost 2 years ago. Before that, I was at the university. And somewhat surprisingly, maybe to many, actually, the things that I'm doing are still very similar to what I was doing at the university. So FAIR gives me really a lot of freedom in exploring the questions that I'm very interested in, which are generally related to linguistics and generalization and evaluation of large models. So yeah, that's what I've been at the last many years, but at FAIR the last almost 2 years.
Excellent. And we definitely want to talk more about large models and get into more detail about generalization. But just to start off, NLP has been a very hot topic for the last couple of years. I always feel like it comes in waves, and as we well know, it's been some really fantastic breakthroughs there. But the question everyone's always asking is how close are current NLP models to a human understanding of language? Where do you think we are at this stage?
Yeah, this is such an amazing and interesting question that I could probably talk about for like an hour, but I will not do that. I know there are some other questions, but I do wanna talk a little bit about like the nuances that are there in that question. So when you're saying there have been a lot of advances recently, I think this is absolutely true. And anyone who's been following the field a little bit, or actually even when you're reading the newspaper, you will see that there's this new model. And for instance, you ask it to explain a joke and it does it. Or you ask it to generate a picture of an astronaut on the moon. I think that one's been in the news a lot. Or an astronaut on a horse on the moon, I think it was, and it does it. And when you look at that, I mean, it's almost, it's kind of eerie, like, because it really seems like it's understanding language. And I think many people are very convinced that they do. There is also another camp of people that are saying that, so an interesting piece of background here is that these models, especially like the language only models, are typically really only trained on text. So basically, they just see a lot of text and they try to predict the next word or some masked out word. And there are a lot of people that are very skeptical on the extent to which that can teach you understanding of the world. It's like being in a black room, never seeing anything, but just getting all the news, all the text in the world, and then do you really understand the world? My take on that, I think, is maybe even sort of a third one. And what I find very interesting about what is happening in the field is that it constantly forces us to reevaluate what it actually means, understanding the world. So an example that I sometimes give is, and I thought that this was ages ago, but when I looked it up, the reference was actually 5 years ago. They said models just trained on text, they will not understand that bananas are yellow, because no one ever says that.
That's right. Very good point.
Well, it turns out that models currently have absolutely no problems understanding that bananas are yellow. And still, the people that said that then are not necessarily convinced that models understand language in the world now. So for me, actually, that's one of the very interesting sides of it, that it really forces us to also sharpen our ideas of what is actually reflective of understanding of the world and what that even is. I mean, actually, even for humans, it's not that this is a very straightforward question.
Yeah, exactly. And that's what, as you said, I find so fascinating about this whole field, because so, as practitioners, how do we measure the performance of our models? How do we know how well they're working? So as you mentioned in your ODSC talk last month, we need good evaluation techniques for NLP. So, related to what you just mentioned, what are some of the good evaluation techniques for NLP? Are they still the standard techniques that you were using back when you were studying for your dissertation, or have they kept pace?
Yeah, no, they're absolutely not, even though I think they are still the most commonly used, which would really be, I have a data set and I randomly split it. I use some parts for training and then I test it on the other part. Maybe I do that multiple times and sort of cross-validation setup, so I filter out some noise that I'm getting from the random splitting. And this for ages, I really think was like the way that everyone was evaluating their models, not only in NLP, but also in the rest of machine learning. And there is definitely a lot of merit to that. We've made huge strides doing this. But at some point, I think actually, especially since we were getting to the ceiling of that, like we were getting all these scores, but then you're testing your models in slightly different situations. And you think, okay, this model, like for instance, models that do natural language understanding like tasks. So for instance, you ask it if two sentences are in agreement with each other. Do they say the same thing or do they contradict each other? So you have your data set to do that specific task. You get like 98% accuracy. So you think, okay, I'm golden. This model, like I can use that. It understands language. It understands what the meaning of sentences is. Then you test it on some sentences that are like slightly different, and all of a sudden it gets like 20% accuracy scores on that.
Right.
So that really makes you think, okay, so what was I measuring to begin with? And yeah, currently I think there's some struggles there. So currently, I mean, there are a lot of benchmark. Most of them are what we call IID, so independently identically distributed samples. So this is this random splitting that I was talking about. But then when you go slightly outside of that distribution, and it can be in all kinds of dimensions. So for instance, if you're training like some toxicity analysis, and say that you train it on Facebook data, and then you want, because you have that, and then you want to test it on Twitter data, that might really not work at all. So we're really, I think we're also at the, like, we're realizing that more and more, because before we didn't have such good scores even on these IID splits. So we weren't aware that good scores on the IID splits weren't the end of the story. Or, I mean, it's not that we were not aware at all, but like there was definitely a focus on getting those scores up. And now that those are so high, we're in need of other kinds of evaluation.
Yeah, and you also mentioned earlier, like these large language models or pre-trained models, they're posing, I would say, new challenges to evaluation and benchmarking, because the benchmarking ones tend to be, that was almost pre-large language models. Would you agree with that?
Yeah, absolutely.
Yeah, and so, by the way, for our audience, please do pose your questions. Any questions you have for Dieuwke, just post them on the channel there. I would love to have them. So just getting into the topic of generalization. Let's start with a gentle introduction. Can you explain the concept of generalization for our audience, and also its importance within NLP, because there's also machine learning generalization, which is a part of, but.
Yeah,
Yes.
absolutely. I actually almost like understanding generalization is also something that I think everyone has a very strong intuition about, but then when you try to really formalize it, write it down, it turns out that it's not that simple. So when you think about it from like a very high level, abstract level, generalization would be the ability to use something that you've learned. So this can be some experience or some knowledge, and apply it in a new situation. So, for instance, one type of generalization that I like a lot, that I work on a lot, is compositional generalization, in which refers to the idea that like, if I'm talking with you, you've never heard the sentences that I said to you before, likely. But still you can understand them.
Right.
And like the theory of why that works like that for humans is that because we can assign meaning to sentences based on the words that are in that sentence and the way that those sentences are combined in a structured way. Like if I tell you Mary likes John, that means something else than John likes Mary, even though they have the exact same words. But we should not confuse them. That might result in some problems.
Exactly.
Yeah, so this is basically what generalization refers to at a sort of like a higher level. Like just as this is for humans, this is also true for models. So ideally speaking, when you're training a model on a particular kind of data, let's go back, for instance, to this sentiment, this toxicity, what we said example before. We want this model, ideally speaking, to generalize to like a wide range of different scenarios. So we don't want it to work just on the data set that has been trained on. We want it also, well, the most simple form is we want it to work on data that it hasn't been trained on, but that's similar to the data that it has been trained on. This would be this IID case that I was referring to before. This nowadays, many people don't even call it generalization anymore. When they're talking about generalization, they're really talking about generalizing to data that is slightly different in one way or another. So when it comes to language, it might be like a different population, or like slightly different heuristics apply or don't apply, those kind of things.
Yeah, that makes a lot of sense, and thanks for that great overview. So you mentioned earlier about splitting, right? So many of us are familiar with supervised machine learning workflows of labeling data and then splitting the data into random training and testing sets. And So in your talk at ODSC Europe, you mentioned some of the problems with this traditional approach. Can you elaborate on that?
Yeah, of course I can. So I think one of the reasons that this traditional approach has some problems is that models, well, not all models, but the models that were like neural networks in the way that we're training them right now, they're kind of prone to latching on to particular correlations that might be in the data set that are not actually reflective of the task itself. So to go back to this natural language inference example where you need to say if two sentences are contradicting each other or not, it might be that in that particular training set that you're looking at, the word cat happens to correlate with the positive label for some reason. I don't know, it just happens. It's a data set, it's collected. Maybe people feel positive about cats. Yet you and I can agree that cats, while I love cats, they're delightful, the presence of the word cat in a sentence doesn't necessarily has any predictive value of the relation of that sentence to another sentence that might be about an entirely different thing or a different cat. So if a model latches onto that, but that particular correlation is present in the entire data set, you will not see that if you're randomly splitting, because it will be the same correlation in the training data as there is in the testing data. I think maybe even a clearer example would be, so these data sets that I was talking about with the natural language inference, they're often generated by crowdsourcers. So basically they set up some experiment on Mechanical Turk, and they ask a bunch of people, this is a sentence, can you generate its contradiction? Or like, can you generate a contradicting sentence? Now it turns out what people are doing is they just put not in front of the sentence, which basically means that any sentence pair that has not in one of the sentences is a contradiction. But then again, this is not like a solid strategy to determine the relationship between two sentences. So if a model is like, this is easy, any sentence that has not in it apparently needs to have the label contradiction with the other, that's not gonna generalize. And those kind of things, like if you train on random splits, it's those things kind of get amplified in a way because models latch onto that. You don't see it in the test set anymore, and to get that out, you need really to look at very specific test sets for which those heuristics or shortcuts do not apply. At the same time, also, like from these examples, I think you might also understand that it's not always very easy to figure that out. Like in case of the not, for instance, to find that particular shortcut or heuristic, that requires quite a detailed understanding of the task itself and of what kind of heuristics there might be or shortcuts there might be to solve problems. So that's really not an easy problem.
No, absolutely, and we see it time and again. And it's interesting what you're saying about annotation. I've experienced that firsthand.
I believe you.
Trying to generate adversarial test sets, which we'll talk about in a minute. Yeah, but as you mentioned, you're trying to split from an unseen test data set, and obviously, as you mentioned, you have all these issues because it may not be the same distribution as the training data. But we definitely see that once we apply our NLP models into production, it can quite likely be, the case where it's not from the same distribution once it's running in production. So I think you've highlighted some of the issues around that, but for the practitioners here, like how best to address that when they're training the model, this issue?
Yeah, this is a very good question. I mean, I'm afraid there isn't a, hey, this is what you need to do and everything is going to be solved, because we're not there yet. I mean, I think being aware of this, I think already helps a lot. So, for instance, what I think is often missing when people are training models is, like, for instance, some analysis of how particular predictions or accuracy relate to particular features of the data set. And this might be something like if you have a data set that is biased in its selection in some way, which you might not even realize. It might, for instance, be that your predictions for particular subpopulations are way higher than for others. So for instance, maybe your predictor works better for male than for female data. So even in your IID split, you can start to investigate these kind of things. And yeah, I mean, also, like, it's in general, it's just very good to think that to realize that if there are some spurious correlations in your data, that your model might really, like, your model will likely latch onto that. So this is just something you should really keep in mind when you're evaluating. And you can also try, so if you have some particular metadata, so for instance, say that you have only Facebook data, but at least you have data from 4 different states. What you can do is, instead of randomly splitting it, put 3 states in the training data and test on the 4th one. And
Right.
if that horribly fails, then you should probably find a different training algorithm or do something with your model. If it works, it's still not a guarantee that it will work for the 6th state, of course, but at least you're getting somewhat closer.
No, that's very good advice, and I definitely want to follow up on that thread a little bit, Dieuwke, but I do have a question here from our audience, from Dieuwke, and I think if we can display that question on the screen, and I'll just repeat it for our audience. So when it comes to big models or large language models, very interesting question. What would you say is the biggest improvement is coming from? Is it inventing different architectures or better training or something else? Which I think is quite interesting.
I love this question. Very, very nice question. Thanks for picking it up. So I think the easy answer is that it's a combination, and I think that this is definitely true. So one of the reasons, it's kind of as you may know, these models have been improving a lot also because they are being trained on more and more data. How well older models, like for instance recurrent models like LSTMs, long short-term memory models, would do on those quantities of data, we don't really know, because computationally speaking, it is not possible to train them on those quantities of data. So from that perspective, it's not completely clear to what extent that's coming from the architecture or the data, or the architecture's ability to absorb more data in a shorter period of time, which is an interesting one, I think. And that to say, data is extremely important. Like,
right,
people, I think, don't really realize that when you're training a machine learning model, like, there's all this exciting work on the architecture and thinking about new models and things like that. But if your data is of low quality, it's not going to work. So a lot of it is actually also really about making sure that your data has some reasonable quality. If you're training a machine translation model, make sure that there aren't a bunch of sentences that are just punctuation, or sentences that are clearly misaligned, and the translation isn't actually a translation, because your model will not know what to do with that, and it is invariably going to lead to larger quality models, at least at the current state. I mean, that's actually, like, it's an interesting point that humans, I think, might be a bit better at thinking, okay, what I'm hearing here is clearly not a translation of the other one, so I'm just going to ignore that, or like, this just doesn't make any sense. Models currently, as far as I know, are not able to do that, and that makes the data extremely important.
No, and I was at a conference, which I believe you've presented papers at before. I was at NACL in Seattle a couple of weeks ago, which is a great conference, my first time at it. And it was quite interesting, because one of the debates there I was listening to and had a few conversations around on the data side, which, again, this is a great question, by the way. So if you have these large language models and they're consuming all the data available in the web, we keep saying that structured data and unstructured data is increasing, but it's not going to increase by 50%, at least accessible. Like, we focus very much on open data. The accessible data, like, how accessible is that, without breaching privacy, because you got to be very careful with private data. So that's something I've been wondering about. Like, the models can improve, but the amount of data available is going to go up, perhaps incrementally, maybe. Because, for example, a lot of stuff is, you can tell, it's trained on Wikipedia. if you've already consumed the whole Wikipedia corpus and everything else out there, what's left? So we could debate that question for a long time. That's very interesting. I think the data one's very, very interesting. But maybe that's a quantity over quality, which you mentioned, Dieuwke. And then on the architecture side, that's been interesting too, because we've had Gary Marcus speak a few times at ODSC conferences. So anyone who's familiar with Gary Marcus will tell you that he believes deep learning is hitting a wall. So if you listen to him and Jan LeCun debate on Twitter, is a bit of a pastime of mine. But yeah, on the architecture side too, it's interesting. But I think there's so much happening. So when you go to a conference like NACL, I think my take from going to that conference, which is always interesting, is it's super interesting hearing about the unsolved problems, right, in the space. And there's a lot. It's so far from being a solved problem. That's for sure.
Yeah, absolutely.
We do have another question here from Himansu, if we could display that question as well, which I think is interesting. Can we display that question, Yura? Yeah, so if you can see that question, everybody. So the compositional generalization, you mentioned how context is different from that. That is hypothetically, if the model is good at understanding the context, how is that different from the model being compositionally generalized? Yeah, so context is always a hot topic if I'm getting this question right.
Yeah, your audience is on fire with these questions. I have to say, not a naive question at all, Himanshu. Actually, I could talk about this for ages, and I think this is a very interesting question that I think even many philosophers would love to talk with you about. So when we think about compositionality, usually what people think about is this idea that you can do, you can build up representations in sort of hierarchical way. Like if you have your sentence, you start at the bottom, you recombine everything, and then at the top, like with arithmetics, for instance, at the top you finally you have the meaning of your sentence. But as you very, very rightfully point out, in language it doesn't actually work that way, because there's all this context, right? So what this word means, it depends on the words that are over there, and it depends on the words that are over there, and maybe even on how those words are combined. So I think when it comes to natural language, indeed, context is exactly what we should be looking at when we are considering compositional generalization. And basically, can a model correctly understand which context should and should not be taken into account? So basically, how local or global should it be with composing? If it composes the meaning of this phrase, tries to translate this phrase, understand this phrase, should it look at the rest of the sentence? Maybe there's even some larger context that is relevant. And at the end of the day, that is indeed exactly what's going to determine whether a model can generalize well compositionally, when it understands when is this context relevant and when isn't. And to finish this answer with an example that again I think illustrates how on point this question is that to some point we were looking at compositionality in machine translation, which is really an amazing domain to research, because it has a lot of wealth and interesting points there. But it's also really difficult, especially when you're looking at natural language, to isolate compositional generalization and attack it in a very specific way. So what we did indeed exactly was we checked if I have the translation of a sentence and how I concatenate that sentence with another sentence. So you put an and in the middle, basically. You say, I don't know, I ate aubergine last night, and every morning I take a shower, or whatever. Now, in theory, the translation of those sentences are kind of unrelated to each other, right? It's not that if I say I ate courgette yesterday and every morning I take a shower, this would change the meaning of and every morning I take a shower. So if you translate compositionally, the translation of the second sentence doesn't change depending on whether I ate courgette, aubergine, pepper, or maybe just a pizza. So what we did is we checked, does the meaning of the translation of that second sentence change? And surprisingly often, actually, it does. So in that case, I think like we were using the fact that a model was using unnecessary context as a signal that it wasn't being very compositional. Because if it were very compositional, the translation of that second sentence wouldn't change. So thanks, thanks a lot for Himanshu for this great question. Gave me also the opportunity to give some actual examples from my own evaluation sets.
Excellent, thank you, Dieuwke. And that was a great explanation. Yeah, just getting back to improving models. So you mentioned a little earlier about adversarial examples. You know, these are things you add to your test set that are designed to fool your NLP model. There was actually a lot of discussion at NACL about this as well, building in adversarial examples for your test model. Do you find that this helps? Or are we really just trying to break the models themselves?
Yeah, this is a very good question. And I have to admit, I have a bit mixed feelings about this. Because on the one hand, yeah, I think it definitely helps, because this relates a bit to what I was saying before, that a model might pick up on a spurious correlation. So if you add a bunch of adversarial examples that a model fails on because they don't fit that correlation, and then you add them to the data, the model is not going to pick up on that spurious correlation anymore because it's not there anymore. So this is like a very clear case of fixing model from the data side.
Right.
Why I have mixed feelings about it is because it's so I would prefer to fix the model itself instead of doing that on the data side, because fixing things on the data side, it's always going to be very well, it's difficult. It's time consuming to find these examples. As I said before, you need quite some knowledge about the domain to even know what those spurious correlations might be. And also, you might still miss a ton of them that you haven't added adversarial examples for. And in that way, it's kind of a never-ending process until you've added all the data that exists, which maybe indeed is what we're doing now. And you don't have these correlations anymore. So personally, what I like more is research that focuses on trying to understand if models can be debiased or like improved in another way. Like, can we make models that just don't have such a strong tendency to pick up on those kind of patterns? And if so, I'm also curious, like, what adversarial examples would look like for those kind of models. Like, we have it also for humans, right? I mean, there's these visual illusions and stuff. That's basically adversarial examples for humans that show that we are using something that doesn't always work. So it would be cool if we could get to a point that for models it was something similar.
No, absolutely. And there was a big debate over, creating adversarial example benchmarks and test sets. But what does that mean? And I think a lot of people have the same kind of misgivings as you're mentioning, and I understand that as well. And it's interesting to me, you have self-supervised, unsupervised learning with an NLP. But when I talk to practitioners, a lot of when you're building your training set and 10 sets, a lot of it is done using annotation. It's supervised learning still, right? So it's annotation. A lot of that's outsourced. So domain expertise and things like that come into it. Are you finding that so putting aside, large language models that you can tune and pre-train and all that stuff for, again, looking at from our practitioner standpoint, that people are still doing supervised learning? A lot are just doing this in spreadsheets and putting in simple annotations. And so if you're still working off a spreadsheet, that makes it difficult to build in more complicated test sets and testing out of distribution. But how are you seeing how industry is kind of embracing these challenges from the annotation perspective, if that's something you can talk to, which I know is difficult.
Yeah, no, it is indeed difficult. And to be entirely honest, I'm not completely sure. Like, I think that, so some approach would be to have the same sample annotated by multiple humans and just do some checking on inter-annotator disagreement. This is also difficult because, I mean, if you have multiple labels for the same example, that might put you in some trouble. So you need to find some way of understanding which one is the best one.
It's definitely topic we're looking at closely. So moving on to something else that was kind of that's been in the news a lot. I think I loved your early examples, but GPT-3 has been out for, what has it been out, a couple of years now? And then, this has been around this topic about these models hallucinating, which I love the term, models hallucinating. I don't know, it's been a topic of research since 2018, 2019, but now, people speak a lot more of it. And just to give our audience an example, there was a blog, I apologize, I forget the name of the author, was an author who was testing out GPT-3, and GPT-3, if you use it, there's different kinds of engines out there, and he was using the Da Vinci engine, and he was looking for Einstein's famous quote of God does not play dice with the universe. And then he asked the engine, does Einstein play dice? He says, no, Einstein's famous quote was, I never throw dice. So if you're using that for your homework or something, you'd be in trouble. So that's an example of how these models, especially these large language models, can hallucinate. And again, I love the phrase, but and I can see the problems there, right? Because if you have domain expertise and you know what the quote from Einstein should be, or something like along those lines, then you know if the model is hallucinating or not. But once you put this out in production, you don't want your model hallucinating. No one wants to be hallucinating. So how worried should we be about this problem? And what do you think they're doing to address it?
I think you should be very worried indeed if you're putting these models in production. I mean, this one is still kind of, harmless in the sense that, okay, you get a bad grade for your homework. But I think there's also some examples around where it's like someone says, I want to kill myself, and the language model says, okay, how can I help? Like, these kind of things are very, very, very problematic. And I think there is I think also this is the reason that many of those models aren't really in production, or at least not without a lot of post-processing to make sure that things go right. I mean, you see this also in Google Translate, or in at some point there was also this scandal with the vision model, I think, that labeled an African American person as a gorilla, which is something which is very, very difficult to solve because these models are trained on a lot of data. And I mean, this also links back nicely to your previous example, the adversarial example. So that, one solution to that would be is to add more African American people in the training data, because this problem is clearly caused by the fact that there aren't, white people are very overpopulated in that training data. But then again, we don't have that data, so it's not really solvable there. Then about the hallucinations, a bit more specifically, I think that, so another side of this problem, I've been thinking about this a lot recently, actually because of the shift to large language models and using them directly instead of fine-tuning them, which results in some sort of weird situation that you're conflating things that are syntactically well-formed sentences and things that are true. Because it's all sort of in the same objective. And I feel that this is a bit at the heart of the problem, because the sentence, I always give examples with capitals. Like the sentence "Rome is the capital of the United Kingdom" is a sentence that is perfectly well formed and syntactically correct. It's just not true. And I think that this is something similar is happening with what you're saying. So it's saying something that it's not like you can say that. I mean, some people would even call it creativity, but it's not true. And this, I think, and this is something that maybe also Gary, who I always love talking with about these kind of things. He has very interesting opinions. Is that so? These models are not actually connected to the world in some other way than that they've seen a lot of text, right? And many people think that at the end of the day, this is not going to work, because also some things might be true at some point and not true anymore afterwards, and they will still be in the text. So how are models supposed to figure that out? And this, I think, is also one of the reasons that Gary and also others are often arguing that we need some form of hybrid model, and something that can interact more with the world, and it has also some component that is not just a neural network looking at tons of text.
Exactly. Yeah. So I guess to summarize, to summarize, we can say GPT-3 and large language models are perfect at writing fiction. if you need that for your homework, but for anything else, you got to be very, very careful. Yeah, so no, that's great. So it's interesting you say that this is something you're looking at as part of your research. So what are areas of NLP research, either your own or other people are doing, that you're excited about that's currently ongoing?
That's also very interesting. I mean, I'm excited. I'm excited about a lot of things. I have to say. So personally, I really work mostly in evaluation. Like I don't try to actively improve models. Why? Because so the reason that I'm so excited about that is that I feel that in this way I don't know, I almost have the largest implicit impact, right? Because if people are using your evaluation data set to understand if their models are improving, basically you're telling them what improvement is. And I think that's very cool. And that is like personally what I'm very excited about. So developing better evaluation set that also help us better understand what the problems are that we have and which one, like how should we address them, like which area should we focus improvements on. I do also think that while I'm not working on that myself, that on the modeling side, there's some very interesting stuff going on, and I really cannot wait to see what's going to come out next. I mean, these models have all been baffling us in the past couple of years. I mean, we went so fast from models that barely couldn't do anything, and models that can really fool you and look like they're a human. And then the third one that I'm very excited about is so there's also colleagues of mine that are really building up like a lot of work on fairness and robustness and these kind of things. And I think that's very important, because another thing that people sometimes forget is that a lot of data is available for English. I mean, you already mentioned before that like at some point, if we don't generate things, that will stop. But for other languages, that's just simply not the case. And yeah, I think that this is a field that it's becoming also bigger. Like it has always existed, obviously, but really like researchers that are working on making this more inclusive, working on low resource scenarios, making sure that models are fair, they don't discriminate, these kind of things. I have a lot of admiration for that. And I think it's really great that this is becoming much more of a thing, and we're not like ignoring that anymore.
No, absolutely. And they're actually they're topics where we have tracks on responsible AI at ODSC West. We're also covering fair AI, and there's other issues around, machine learning security. We were looking at one where some of these large models, privacy issues around them, poison data attacks, all of this, which feeds into NLP. And you're right, Dieuwke, there's a lot of exciting stuff happening in the field of NLP, definitely challenges there as well, as you just mentioned. So Dieuwke, for people, we're definitely going to continue to follow your work, but for those of you out there, this is their first time hearing about you, what's the best way to follow your work and get in touch?
The best way, I think, is to go to my website, which my first name and my last name .nl. Oh, it's already appearing there. Pretty much all the links of stuff that about me, you can find them there. There are also a bunch of videos of some talks that were recorded, and I had the permission of sharing, or some podcasts about my dissertation. I'm not really a blogger, but if something's happening, or I'm giving a presentation, or a new paper came out, or something like that, you will find it there.
Excellent. Well, Dieuwke, thank you so much for coming on the show today. Thank you for being an ODSC speaker, and can't wait to have you back at one of our conferences in the near future.
Thanks for the invitation, and thanks for the great chat. I'm always very impressed how people can ask such good questions about topics that are not necessarily their own to start with. So yeah, that was great. It was a very nice conversation. I really enjoyed that.
Yes, and thank you to all our audience, and we'll see you in a few weeks for our next conversation. So thank you again. Bye now.